Hello everyone, this is Dr. Sri Banerjee, and today I will be presenting on machine learning algorithm for diabetes prediction using social risk factors in a nationally representative dataset. But first, a little bit about myself. I am core faculty for Walden University and I teach doctoral level students. I chair and mentor students and also teach surveillance and other subjects like statistics. I also have a background in geospatial statistics from Hopkins and a background in medicine as well, and epidemiology. So today we will be going over numerous things surrounding machine learning and artificial intelligence in general. I will be going over some of the different types of machine learning categories that are out there and can be utilized as powerful analytic tools in order to make prediction even more accurate. And then also we will be going over how machine learning can be used for actionable health policy change. This is very important because recently there is even more of a push for understanding how research can be translated into policy. And this is also reflected through the theme that we have for this year's conference, which is data is there and how you can interpret data for stories. And so artificial intelligence allows these stories to be told from the data that is present. Additionally, I will be going over how a nationally representative dataset can be used to not only analyze but train and test predictors of diabetes. Finally, I'll be describing the pertinent findings that are typically presented with random forests. So here is the abstract. I will put this up for a few seconds so that you can take a look at this again. This is the research I'll be going over through the next slides. So in this slide, I am going over how you can understand selection of nationally representative data sets for health research. So as you know, survey researchers are interested in analyzing survey data sets, and the reason we do so, and I use nationally representative data sets all the time with my research and my students' research, and it's really important because you can make robust estimates for the population, and they're so useful in understanding disease patterns, not only in diabetes research, but other types of research. So there's examples of nationally representative data sets like the National Health Interview Survey, Behavioral Risk Factor Social Survey. And these are specialized analytic methods that you have to keep in mind. And how machine learning plays a role in that, I will be describing in subsequent slides. SAS, Python, SPSS, R, these are all robust packages in statistics which can be all used for machine learning analysis. Some are more suitable than others. In my experience, Python has a lot of not only tools but tutorials out there that allow for machine learning. But other packages are just as suitable. SAS has a lot of historic development with machine learning and is good to use. So machine learning methods, there's a lot of different flavors that deviate from the classic statistical inference that we think of. And It's good to think of artificial intelligence and specifically machine learning as additional information that can be integrated into classical statistical inference. So a lot of recent literature has focused on how artificial intelligence can actually augment and enhance our decision-making processes. And this is the same that goes to be true in statistics. A lot of these ideas have been borrowed from computer science and engineering, and um, learning from data as opposed to casting the data into a linear or structured sort of formation. So using the data to understand the situation rather than making assumptions is the paradigm shift that we think in machine learning. So understanding supervised learning requires some understanding of the setup that is in this type of environment. So the output measure y, you can think of it as the response or dependent variable, and then the vector of p input measurements, x. So these can be thought of as, in traditional sense, the regressors, the covariates, the independent variables, etc. Y takes values in a finite, unordered set. And so it could be either binary or continuous. And then you have a training data. And so you split the data set into smaller parts. And so certain parts you use to train, and then the other part you test your data set. And this is something that is pretty common in diagnostics. And these are observations of these measurements. Main type of structured supervised machine learning that I was focused on in my work with diabetes was the random forest. And this was more part of the tree sort of the random forest versus trees model that I was using in my approach. So the prediction, classification, and assessment of variable importance are critical questions that need to be understood in statistical inference. So this is a recursive sort of approach where there is a span of multiple variables that are narrowed down and split into regions. So I'll show you the approach in a little bit more detail in subsequent slides. In this slide, through that iterative process, the recursive process that I was explaining, you have a classification tree within the random forest. And so this shows 3 class labels and 2 predictors and how that's partitioned. Pretty soon I'll show you how in my tree and in my forest, how these nodes were split. So please keep this in mind. So what are some additional basic principles of CART? For regression, the best split points are chosen by reducing the squared or absolute errors. But for classification purposes, the points that best separate, and that's the entropy or the Gini, are the classes that are chosen to best split points. So you grow a large tree and then you prune it. And pruning can be done by randomly selecting a test sample, computing the error, running it down the large tree and subtrees. So this is, as you can see, a recursive process. And then you find the tree with the smallest error, and that will be the final tree. And I'll show you my tree. So at this point, what I'll show you is my findings, and then I'll work backwards to show you some other key components of this sort of random forest application. So here, as you can see, the measure of decrease in Gini, this measure of sort of entropy. which is a further conversation and lecture for another time. But here it shows, you can see this as a relative importance of the variables that are included within the predictor. And so as you can see, age, for diabetes, age is something that is extremely important. And so with advanced age, you see more diabetes, and that's a fact. But what was surprising is household income was actually second. And so this was even more important than some other medical risk factors that are there, or behavior risk factors. So things that you associate risk factor behaviors with disease. For instance, smoking, or even other risk factors, were not seen as important as household income. What does this imply now for research is that equity-related research, income inequities need to be addressed adequately in order to address disease conditions. And this artificial intelligence application demonstrates that very fact. As promised, here is the tree that was created from the dataset, and you can see that there are some decisions for split points that were created from not only age, where 61 was decided as the splitting point between risk for diabetes and less risk. Similarly, race, household income, that's interesting. 26,000 was roughly the income where there was a split between two nodes. So it's interesting to see where all of these splits take place, and some insights can be attained from this as well. So in conclusion, artificial intelligence can be harnessed to better understand social problems. In my research, I was not only able to identify socioeconomic status as a potential important prognostic indicator for diabetes, but also there were inflammatory biomarkers, which I have been following since my dissertation, where I wrote on C-reactive protein. So there are certain early warning indicators that can be further investigated in the context of machine learning and random forest. So using machine learning, we really can identify common factors that connect mental, physical, and social health. And this has increasingly become especially important in the context of the pandemic, and how all of these factors have come together in order for people to try to become more creative to understand and come up with solutions to translate into not only actionable policy, but making a difference in making the world a better place. Thank you.